Hello, everyone. Welcome to Taming the Complexity Beast, how organizations are rethinking software architecture and deployment. I'm Katie Norton. I am an analyst at IDC. I run our DevSecOps, software supply chain security research practice, and I am moderating this wonderful panel today. I'm going to introduce the lovely folks on stage so we can dive right into the questions and the good conversation. So first, we have, right next to me here, we have Jason Hall. He is a principal engineer at Chainguard and expert crossword puzzler. Next, we have Jon Ceanfaglione. There we go. Chief Architect, DevSecOps and IT Automation at IBM. And he works with large organizations on cloud-native transformations. And then lastly, but not leastly, we have Alex Zenla. She is the co-founder and CTO of Edera and a technology nerd. All right, well, let's dive right in. We're gonna start and set the stage a little bit. You know, we have lived through this microservices, all the things era. And Jon, I want to start with you from your perspective at IBM and working with enterprises. What does the complexity landscape look like today? And what do you think is contributing to organizations sort of rethinking those architectural decisions?
So I think in the microservices era, we created a lot of problems for ourselves that we didn't necessarily have, and we solved a lot of problems that we maybe created for ourselves. And what we're seeing now with a lot of the organizations that I deal with is they thought that moving to microservices was going to be this panacea of solutions, and what they got is they're still sitting on mounds of technical debt. They're sitting with these huge Splunk bills, these huge New Relic bills, and all of this complexity, and they didn't get anywhere. And so the number one thing we're hearing is, can you help me reduce my cloud spend? And they're still saying, I need to do more with less. We're still there. You always help me do more with less. And we're just praying, I think, that AI is gonna solve that problem. But I think we can really kind of boil it down to three things. One, right now, the challenge is that observability is a treasure hunt. We traded, debugging stack traces for distributed tracing. We're looking across, 10 or 20 services, just, looking through distributed traces. And that is praying that the development teams instrumented their code properly. I think the second thing is that we have an explosion of security boundaries, right? One service becomes secrets, certificates, a security boundary, a perimeter that needs to be secured. So we went from securing the perimeter to securing 50 perimeters. And so we took what was simple and we exponentially made it, far more complex. And so that is, what the challenges that we have today. And so that's what, all of the organizations that I'm dealing with today are feeling. That's the pain that they're feeling.
Jon or Jason or Alex, do you have anything to add?
I think that we keep adding layers of abstraction, hoping that the problem will go away, and it never does. I think of the standards XKCD all the time, and that's pretty much what we keep doing. I feel like every new project that we create, it's never replacing multiple tools. It's like, how can we add another tool on to solve all of our problems? We had a good laugh last year where there were multiple talks that were basically, we're going to put clusters on clusters on clusters. Clusters are not the solution to this problem. I'm just going to set that out very clearly.
But what if one more layer of clusters? I just think
Just
the problem
one
is
more,
only
bro.
3 layers of clusters. Amateur. Yeah, I think it's even worse than adding a layer of abstraction. Most of the time you are buying a layer of abstraction. You are like paying someone for the privilege of another layer of abstraction. And I think, yeah, like how to get out of that death spiral is to like think about, like, literally stop and think, what am I trying to do here? Like, what is it I'm actually trying to do? I take some user's code and I run it. Okay, what's the simplest possible way I could do it? Instead of like, well, I have to have this and I have to have this and I have to have it be 18 microservices and a, you know, message queue and a whatever. Like, what is it I'm actually trying to do here? And then, I mean, it's easier said than done, and there's a lot of complexity to that question, but I'm sure we'll get into it. But yeah, basically, doing less, doing more with less means doing less.
Jason, I'm going to pick on you a little bit more. That you mentioned on our prep call that there, isn't a one-size-fits-all solution to this. I just wanted to have you walk through this, what you think this like complexity-aware architectural decisions, what does that actually mean in practice, and how should teams approach this differently than they have?
Yeah, I think a lot, like I was saying, like, think about what you're actually trying to do. Think about along which axes it needs to scale on. If it gets regular, steady traffic, maybe you don't need an auto-scaling cluster for that. Maybe you need one box, right? Not a cluster of boxes that can infinitely scale into the moon for your blog, but maybe just one box that does that thing. There are also cases where like you do actually need to, traffic is cyclic throughout the day, or you expect huge bursts of traffic, or you need to be able to scale up very quickly for this particular service. And so it makes sense to go all the way maximum microservice and take advantage of that. That's fine. But I think your point is like, I think we all like drank a bit of the microservice juice and thought it would solve every problem. It solves certain problems. There are definitely things it does well. But it doesn't do everything. And now if you're using the wrong tool for the job or the wrong architecture for it, you're fighting the architecture instead of like taking advantage of it, basically.
Yeah, I think there's an uncomfortable truth that we have to recognize is that we didn't all need to adopt Netflix level microservice architecture. And maybe we did it because we were afraid that we were all going to be left behind. There was sort of this misconception maybe that microservices equals move fast equals competitive advantage. And so we just did it. And, that got us into a lot of trouble. I understand why it happened, right? Like 2 weeks ago, AWS went down, and all over LinkedIn, everybody says we need multi-cloud. Well, in 12 months, somebody's going to look at their cloud bill and go, who did this? Who do I fire? Right? This is ridiculous. So, we're going to do it again. Those are the mistakes that we continue to repeat.
Yeah, I mean, it's kind of comical for me looking at the current landscape. Sometimes I just legitimately wonder, what are we doing with our lives right now? But I try to stay optimistic that we can change it, which I'm sure we'll get into.
Alex, so, we talked about clusters on clusters on clusters, but containers aren't going anywhere, right? So the ecosystem, it's just too robust at this point. So I want to talk a little bit about the problems containers do have, and how can organizations make their container-based architectures simple and secure without going totally overkill?
Yeah, I mean, so I worked at Google for a bit of time, and I remember one time I logged into the Borg console, which is basically like the Kubernetes console, and saw that our little tiny service was using just 17 terabytes of memory. And what I think we need to remember is that you can just run things on a few servers. A lot of things that you need to do can just be run on a few servers. If you want to throw Kubernetes on there, sure, but not everyone needs to scale up to like 50 nodes even for something very simple. Talked to one company whose website alone runs on like 30 different EC2 instances. It's just a simple website. You can just cache that thing. What are we doing? So I think the fundamental problems of the container ecosystem are, for me, because I'm very paranoid, security. I just did multiple talks about how containers are not security boundaries, and that containers aren't a Linux kernel concept. They are just a bunch of different Linux kernel concepts merged into this concept that we think of as a container. What I think is most important is we need to develop proper foundations and think across the entire stack to solve our problems. I think everyone knows the story of Docker, roughly, probably. Docker was one single project that then got split out into multiple projects. If you install Docker today, you are actually running Docker, containerd, and run C. The more layers that we add to the system, and by the way, not all of those are maintained by the same people. The more layers that we add to the system, the more complex the security problem becomes. I've really dedicated what we're doing at Edera to trying to make a secure container foundation that works at the very lowest layers of the system. I think we have to go back and think about what we are doing from the fundamental levels, and still provide the ability for you to deploy your application, container image, whatever you're trying to do, just as you should are doing today, but in a more secure environment. I think also tool sprawl is a huge problem. We've talked to some people who literally have every observability tool that exists on the market somewhere in their deployment. I think it's a little bit ridiculous. And I also think that we are creating big checklists and big lists of problems for developers to fix in the security space through these observability tools, rather than giving people solutions to actually solve those problems. We're basically forcing developers to focus on the security of their platform, of the platform itself, rather than giving them solutions to solve it. So there's a whole bunch of problems with the container ecosystem, but I think the biggest one is just focusing too much on just adding additional layers instead of thinking about what we're trying to fundamentally do.
All right, we'll keep going on security here. One of my favorite topics, shift left, which there's actually been a lot of anti-shift left narrative lately. I think the industry misunderstood, right, what we were trying to accomplish with that. And I think it's because we shifted problems instead of solutions. And so developers have ended up with more findings, but not a lot more help. And, but I don't think that abandoning shift left is the answer. I think we'd all agree with that. That was never the intent, but how we implemented it. So I'm going to embrace for this question, my inner Steve Harvey here, and welcome the panel to KubeCon Family Feud. I don't have a buzzer for you. Top answers are on the imaginary board. We asked 100 organizations, what should have never been shifted left? Anyone? This is for open.
Certificates.
Yeah, elaborate.
I mean, we just had a production system go down like last week because a certificate expired, and it's because we left it up to the development teams to manage their own certificates, and they leave it up to setting a reminder in Outlook to tell them that they need to rotate a certificate, and nobody gets the Slack alert because why? Because they're drowned in security alerts in their Slack channel, and they missed the fact that they got an alert that said you need to rotate this certificate in 7 days or whatever. It just kind of highlights the compounding problem of, drowning in the noise and you miss this actual signal that you're looking for.
Survey says that was number 3 on the list.
So scientific. I'll say cost. I think similarly, right? The team all the way left in this exercise has plenty of other things to think about, to worry about all the time. Cost is not going to be in their top 10 until it becomes oh my God, this service magically cost $100,000 yesterday. What the fuck? And then it becomes a fire drill. I feel like cost has to be something that is holistically considered, aggregated and thought through, and because it's important to the business, and also each team can't really say what their service should cost, right? Like each one, it's very important to that team that the service is running great. But at the top level business perspective, it's got to be like, why are we spending $80,000 a day on the blog host thing? Like that's not important to me up at the top. So yeah, I think I'll say cost. How'd I do?
2. We're going in order. You give us the number 1, Alex.
It's a tough one. I'm going to say networking.
Oh yeah.
Yeah, that's a good one.
It is 2025, and if you install Kubernetes, you don't get a default networking system. We should be ashamed of ourselves. And if you choose a cloud provider, you do get one, but you usually get their crappy one. And there are a lot of networking companies out there, but I think this has become a fundamental problem that I know that Jon over here really feels strongly about. But I have some other ones, but that's probably the biggest pain.
That's a good one. We didn't even talk about vulnerabilities, but
Oh yeah, those.
yeah, those too. That's probably in the top
Goes without
there too.
saying.
Yeah.
Those were very good answers. So, Jon, you said during our prep call that we keep creating these problems for ourselves, and we need to stop doing that. So, what, in your opinion, are these key lessons from the last decade of Kubernetes that teams absolutely need to carry forward, especially as they are building new platforms?
So I want to actually start on a positive note because I get told that I'm too negative. So just starting with what I think is this is a really positive thing, and that is that just going back to what containers solved for us, and just going back to Docker, it solved a fundamental problem, which was packaging, right? So you finally you solved the run, build once, run anywhere problem. And so you could take your application, package it up, and it had everything it needed to run, and you could just ship it. And the first time that I experienced this is, we had developers that had laptops and they were building, and I had a dev and test environment that was virtualized. And then I had the black hole, which was the on-prem data center. And it was a government data center. And so it was only hands and eyes. And so I was on the phone all the time. And so you could never have any confidence that what you were shipping would ever get installed properly. But so then with Docker, right, the ability to just ship them a container and then know that they weren't going to screw it up was like incredibly powerful, right? And so separating convenience from that overhead is an incredibly powerful lesson. And so, and that simplicity is what Edera and Chainguard, that's the messaging that we're hearing from them today, is removing that simplicity from the overhead of security at both the container level and then the runtime security level. And that's the message that those two companies are bringing us today. And I think that's a really powerful lesson. And so that's one really positive lesson that we carry forward. And so Docker solved that before Kubernetes became wildly popular and solved the scheduling, the orchestration complexity problem. I think the pain lesson that we need to carry forward is that it's wild to me that we built this platform that we could run at massive scale, that we were going to have multi-tenancy without any sort of isolation guarantees, and then we didn't include security by default. We just said, oh, we're just going to run everything on it. Security should be default and have escape hatches for like the 5% of the cases that those workloads need security hatches. Right, and then those are the ones that we need to have like exceptions for. Like we shouldn't throw a platform at people and say like, here's 47 knobs, you figure out how to run it, go learn Kubernetes. Like it's your problem. We're creating all of these challenges for our SRE teams, and like we made them complicit in all of these architectural decisions that they had no control over. And so there's a lot of fatigue that's happening or that we're seeing with Kubernetes right now. And I think Kubernetes is a great platform. Like I love it, but right now it's just my customers hate it, and so it's an interesting dichotomy that's in this space right now.
Yeah, I think you said something earlier also that I wanted to highlight, which was Docker. Like a great thing about Docker's fantastic, is that you solve the packaging problem, right? And you said, take everything I need and send it to the place it needs to be. There's a really important like that you need part of that statement that I feel like a lot of people just sort of like gloss over. There's that meme that's like, well, it works on my desktop, so I will package my whole desktop and send it to you, right? It's funny because it's true. It's funny because that's like literally what people do. There's, like from Ubuntu, from Debian, from Alpine, right? Like, I don't need grep to be available to me in my application, right? Unless it is, in which case reconsider your life choices. But like, I think we got so excited about packaging everything that we forgot to package only what you need. It's really hard sometimes to figure out what you actually need when you have had a whole, desktop environment available to you. But that's sort of another example of figure out what you're actually trying to do. Literally step back from the computer and think, what is it I'm trying to do? And draw the smallest possible box around it. And then, make that the thing you build and package and ship to your customer or your end user. And not just like, well, it runs and I don't know if it needs everything, but I'm going to give it everything. Run as root, run as whatever, it works. So it must be secure. It must be good. It must be right. But that's another spot where like, if that had been the default somehow, if we had made it like, you get nothing until you opt into all the stuff you need, I think we would have been in a much better place with regards to security and maintainability and everything.
I think us low-level engineers screwed everyone over because we told you that everything was fine and everything was secure, and it wasn't.
Yeah.
It's her fault.
Yeah,
It's her
my
fault, everyone.
We told you that you can trust the Linux kernel, but you can't, and we set people up for failure, I think, by making it feel too secure when it wasn't. And so people today, even sometimes I'll have conversations and I'll tell them like how bad everything is. And they're like, I had no idea. And it really is sad, the state of container security and every new vulnerability that comes out in the Linux kernel scares me. We had a stat that was like, I want to say it was like 30 to 60 CVEs a day or something at one point in the Linux kernel. Some of those are ones I found. So yeah, terrifying stuff.
See, it's your fault. If you stopped finding them, there wouldn't be so many.
I just got to stop looking for all the problems, and I promise they're not there.
But I think that, like, a lot of people like to disagree and argue. We all like to disagree and argue. That's why I'm here. That, like, the Linux kernel is or isn't secure. And I feel like a lot of people say, well, sure, it can be secure. You just need to read this 8,000-page book manual about how to secure it and find the 7,602nd knob and turn it to the left 8 degrees, and now it's secure. Right.
Add this flag to your compiler.
Exactly.
Yeah.
What's a compiler?
Yeah.
What's a C flag?
What's a C flag?
And so I think like it, it's not like whether it is or isn't secure. It's like how easy is it to be made secure by default or out of the box.
We are a cheery bunch today. Hopefully, we have not depressed everyone in the last. Almost we are almost at the end of this panel. We've got about 7 minutes left, and we have not been asked about AI yet. So that was on purpose. But we're going to ask about AI now. So seriously, though, a lot of organizations are building AI on top of containers and Kubernetes and platforms. And this infrastructure. So what is your advice for not repeating some of these same complexity mistakes that we've made over the past decade as we move forward?
Decide whether you need it before you adopt it, right? Like, I think containers was the same way, right? We all got excited about it. I got excited about it. I microservice too close to the sun. But like, there are things like that AI is going to be uniquely good at. There are things that AI is going to be, obviously the right choice for. There are also going to be a million things that it is not the right choice for, and that containers weren't the right choice for, that we use them anyway. So I think like, go explore, try things, see what it's like, but don't ship it to production if you're not totally sure that you want AI doing that job versus like a bash script or a program in real life code. That's my answer.
John?
Yeah, I'm going to say, don't be afraid to be the naysayer in the room. What's going on in the MCP community like scares the shit out of me right now. And we're all okay with it. Like we're all just going along with it. And you talked about like all of the CVs that you're finding. Like we're finding really scary vulnerabilities every single day, and we're still shipping AI into prod with all of these MCP servers adapted, and it's really scary. And so you just have to be deliberate, I think, about security first, security first, security first.
I don't want to be a pessimist, but I'm absolutely terrified of the future. I think some of the things that people are doing in production is horrifying. But I think we as an industry here in Cloud Native have to provide, we can't make the same mistakes. We really do have to provide a secure foundation for people. And we need to be a little bit paranoid, I think. It's unfortunate that we're in this situation, but things are moving so fast that we have to be scared. And I personally think that security is going to become more and more of a problem every day until AI hits that point where it's just completely normal. But I don't want to see privacy be sacrificed either. I'm a huge privacy advocate, and some of the things that I've seen some LLM stuff do, I do not want to see done.
We'll just solve it with more AIs. Have AIs watch the AIs.
We'll just same
AI on
with the
top
cluster
of
problem.
AI on top of AI.
Yeah.
Four levels that we gotta go.
4 levels, yes. We've got 3 minutes before we're booted. If anybody has a question in the audience, there is a lovely microphone right in the middle because this is being recorded. So I'll give anybody the opportunity.
I'll just shout it out so I'm not wasting time. Do we just wipe it out and start over again? Do we renovate or do we just demolish?
No, I think that. Sorry. So the question was, do we renovate? Do we just wipe it out? Do we just RM, RF, prod, and start over? I don't. That's an oversimplification. I think it. You have to keep making the thing you're making. You can't stop the world and burn it to the ground and rewrite it good this time. But I think there is, you can start designing new systems to reduce complexity. You can start designing when you're building the next thing. Think, how would I have done this if I had learned from all the mistakes of the previous things? I think, yeah.
Yeah, for me, it's that we never consider operational complexity as an architectural concern. And I think that's the most important thing. You just have to include that when you're thinking about everything. What am I doing to operational complexity when this decision is made? I think that's really important.
I think you can build better, but you have to build a bridge. And not an awful bridge, like an actually compatible bridge.
Looks like we have another question.
So how do you handle the socio part of the socio-technical structures? 'Cause to me, microservices is a purely social problem because we're trying to have anonymous teams push faster. You're not stuck in social overhead. How do we go about that better going forward, since so many of us work in large companies with 1,000, 10,000, whatever engineers to help fight that? That's where I think most of this comes from. What do you guys do to combat that?
Yeah, I think that's the exact part of shift left we got wrong. I think that's what we meant when we said shift left was let's shift all of these decisions left. Let's get everybody in the room further left. Let's get security involved earlier. Let's get the ops engineers involved earlier. Let's do all of those things sooner. I don't think there's any. Unfortunately, I'm not going to give you a great answer. I don't think there's any one simple answer. Everybody's organization is different, right? It's Conway's law. You have to look at how your organization operates, and that actually dictates like how the structure needs to look. That's the problem, is everybody's organization is different, and how your organization is structured dictates how that needs to look. I don't think people pay attention enough to things like Conway's Law and how that should dictate the technical architecture of your teams and all of those sorts of things. So that's what I think the problem is. I don't necessarily know that I can tell you how to solve it, because I think it's up to everyone's, organization to figure that out for themselves.
Yeah, I think it's also really, I mean, thank you for asking that question. It's a great question. I think it is a mistake to try to solve socio-human problems purely with technology. Technology can help, but like, if teams don't trust each other, if people write and review bad code, Kubernetes is not going to solve that. Sorry, like none of the things that are made of code are going to solve that. So yeah, it's about like taking time to think, having time to think about how this will work with other teams, and talking to each other occasionally is nice. Yeah, you're not going to solve it purely with a technological solution at all.
People problems, everyone sucks at people problems, especially cloud natives. So I don't know that we're going to solve this really. But I think you have to try, at least. Try something. But navigating political structures in companies is notably one of the hardest things to do.
Yeah, it's not great at IBM either.
Well, I want to thank everybody for their time. I hope we didn't make you too sad. Go on and leave your day happy and joyous, and thank you for spending time with us.
Yeah, thanks.